Hello. Hello.
Yep.
Hello.
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 You good?
Just gonna give it a couple minutes. Just pas over een half uur. Hey, over de.
6 minuten.
Okay. Ja. Oké, uw flessen hebben staan?
Die heb geen anders.
Ja, ik heb een iPad, hè, dus dat is wel een beetje mottig voor die te gaan aanzetten. Een beetje mottig. Good to go? All right, let's get this going.
Alrighty, thank you all for joining us. We're going to be talking about how we, at our customer, deployed NSX and how we manage it today using Terraform. We're a big proponent of this, so that's why we're here. Quick overview of our agenda. We're going to have a short slide on who we are, why we might be trustworthy, or not, I guess. Some of our reasoning and our strategy into our data center automation in general, why we're doing this. An introduction on what Terraform is, because for a lot of people we've noticed they don't necessarily know Terraform and how it works, why we want to use it. Information on the architecture of Terraform, which is fairly fundamental to understand the demos later on. Then some info on how we actually deployed this, why we deployed it that way, how we applied it to NSX, and then not on this slide, we have a few demos to show how we actually run this, both in a sort of lab environment, but also in a real world example.
And my clicker doesn't seem to work.
Yeah.
Oh, it does.
All right, so who are we? Despite what that picture says, we are not a couple. It might look like that, not the case. I'm Evert Amssoms. I'm a freelance network engineer these days, more data center infrastructure in general. I'm a V expert since this year. Yay, thank you, Corey. I hold a VCIX and V since last year as well, so I like to think I know what I'm talking about. I probably don't.
There's also, of course, the Rocketdyne F1 engine, which you all remember from the Saturn V. My name is Maarten van Driessen. I'm a freelance infrastructure consultant. I've been a V-Expert since 2017, also a V-Expert Pro, VCIX certification. You can look that up on LinkedIn if you want to know that. And I'm also one of the VMware leaders in Belgium. So let's get started with why we wanted to automate. So when we decided to roll out NSX, we were starting to think about how are we actually going to manage this. And with microsegmentation especially, we want to build firewall policies across every single application. We do have quite a few applications in our environment, so we could see that number of rules growing exponentially. So we thought of a way to try to automate this. We thought about using PowerShell, which is not very scalable for the way we wanted to do this. So there were also a couple other challenges that we had to deal with. We wanted to keep up with the rapid changes in our environment. We're going through a growth phase as well as a couple application refreshes. So anytime we have to make business wait for new virtual machines because we have to deploy firewall rules, that's a tough conversation to have. So we also wanted to enable a secure default state by doing this. And what I mean by secure default state is we don't want anything to talk on our network without explicitly defining firewall policies. So default secure is nothing can talk to anything, and they have to talk to us to create firewall policies to get their application to work, when this is part of the goal of this project as well. We also wanted to empower our application owners and our developers to just be able to request firewall policies based on a set of variables that they just have to enter. And those were some of the ideas we had at the start. But we also had a few others. We wanted to make permissions a lot easier. We didn't want to have to deal with a lot of RBAC roles, and that developer needs role X, Y, and Z. Another person needs these permissions. We just wanted to get to some place where we don't give anybody write permissions. We just want read-only for everybody, even for ourselves. We want to work across silos as well. He's a network engineer. I'm mainly a virtualization engineer. We've got a couple other people that are backup focused, but also still need to touch this. So we wanted to make it easy for each of those different silos to work in the same platform and also get a bit of cross-contamination there. And responsibility and accountability was also a big important step for us. We wanted to know what everybody was doing at every single step of the way so that we could go back like, hey, the application broke 20 days ago, you made a change there. Why did you do that change? And those were a couple of challenges we started to think of or identified. Now, we quickly landed on Terraform. So quick introduction to what Terraform is, if that clicker would work. It is, in our view, executable documentation because you just write the code it gets deployed. If it's not in code, it will get overwritten. So you can just look at the code and you will know what you want your infrastructure to look like. So that is easy from that point of view. That also brings us to infrastructure as code. It's in the name. So what is in the infrastructure will be in code. So that's convenient. It is a fully open source provisioning tool, used to be. I hope IBM changes that back soon. And it serves as an abstraction layer between your APIs and your engineer. So instead of using PowerShell or some other CLI tool, Terraform acts as that abstraction layer between the APIs, which is what it talks to. It is a single binary, so you can just go to terraform.com and or hashicorp.com, whatever it is, just download the exe file or the MSI or whatever you want. You could just run it and do whatever you want with just that single binary. It can be run locally. As I said, you can download it on your laptop. We did not want to go that way because of the permissions thing. So you can run it in a pipeline, or even better, you can also use it in another platform like HashiCorp Cloud or Atlantis and stuff like that. We'll get back to that in a few moments. Now, Terraform in itself is just an executable. It doesn't know how to talk to vSphere, for example, or NSX or whatever. So that's why you have providers. Every vendor can make their own provider, which is just a Go binary or a Go project that is talking to the APIs. And every vendor is responsible for maintaining their own provider. So the provider will implement the CRUD operation, so create updates and delete. And Microsoft will just maintain the Azure provider. Amazon maintains the AWS provider. VMware maintains the NSX, AVI, vSphere providers, and all that stuff. And then if it would work, this is yours.
All right, so Terraform architecture. There's a few very important concepts about Terraform that you must know before you get started with it. Number one, state. Terraform uses state. State, that's essentially a file, and that is the world as Terraform knows it. Anything that Terraform is managing or has provisions is going to be in your state file. If it is not in state, Terraform thinks it does not exist. This is also how you get to that state where if someone makes a change manually, it may get overwritten, it may get deleted. This ties into our whole, we want to limit roles in our infrastructure, because if people can make manual changes, things will go bad. Your state can either be a local file, it can just be on the file system of whatever machine you run Terraform on. That works for your labs, for your super small deployments, for your testing. Or you can have it on a remote backend. That can be an Azure storage account. That can be an Amazon storage bucket, whatever you want. Ideally, you want your state to be encrypted. And you want it to have some sort of a locking mechanism, because you don't want multiple instances trying to edit the state at the same time. State, as I mentioned, is absolutely critical. If you break your state in Terraform, you might break your provisioning. If you break your state bad enough, you might break your data center. So that's an important caveat. Also important, your state contains all your secrets in plain text. Terraform does not encrypt any passwords that it writes to state. This is a design choice. This is why you want your state encrypted. This is why you don't want a human to be able to touch your state.
Oh, yeah, it is a bit finicky, the clicker.
There you go. So next up, your Terraform config files. The main part of Terraform you'll probably be interacting with if you run this. Your config files contain your actual provisioning code. This is where you define what you want your infrastructure to look like. These files get interpreted by the binary that Maarten was talking about before. They can have a .tf extension by default. They can have a .tf vars extension to actually assign your variables. And they can be written in either HCL, which is HashiCorp language. It's a DSL language that HashiCorp developed to write code for their own products, and not only Terraform, but also Packer, for example. Or they can just be in JSON if you want to generate something that can just be interpreted by a machine.
I think that works easier.
So, next up, the plan. Antoine de Saint-Exupéry once said it, a plan without a dream is just a wish. Next concept is plan. When you run Terraform, you initialize it to tell it what it needs, and then you run a plan. The plan is going to look at all the TF files that exist in the folder that you're running it in. It's going to parse those, and then it's going to compare all those files against what is in the state. Once it's done that, it's going to build a graph. So essentially, it's going to look at all the stuff you want. It's going to compare that to state, and it's going to make a dependency graph to make sure that everything either already exists, and then you're done, brilliant, or it's going to check what it needs to create or update or delete to make sure that your state is going to match what is in your code. Once you do it, you've got a plan, you're going to execute that plan. This is when you run Terraform apply. When you run apply, you're going to either grab a plan that you made earlier with your planning phase, or you're just going to do it on the fly. You can do it on the fly, and then you can auto-apply, and that's how you break things. Ideally, you run a plan first, and you have someone review that plan. And once you've got your plan, you're going to apply that, and you're going to record all these changes that you make in your state file. So that's your main steps. You're going to write your code. You're going to plan what you're doing with your code, make sure that it does what you want it to do. You're going to apply that code, and then you're going to record, or Terraform is going to record all those changes in its state file. And then ideally, your state file, your code, and the world match. Apparently, I forgot to update the title of this slide. So next up, modules. If you want your code, if you've been thinking to this, or you already have a grasp of Terraform, you might be thinking, well, that sounds like a lot of work. I don't want to be writing down code for every single piece of my infrastructure I have. That's going to be way too long. That's going to be way too time consuming. That's not going to scale. This is why you use modules. A module, it's a folder. If you've ever written PowerShell, it's the exact same thing. You put code in a folder. That folder is now a module. Why do you want to do that? You want to adhere to the dry principle. Do not repeat yourself. If you want to deploy a virtual machine, you don't want to be writing a single file for every virtual machine you're deploying. No one wants to do that. That doesn't scale. You write a module to create a virtual machine, and then you just run that module. You give it a few parameters, and you run that. Why do you do that? It saves you a bunch of time. It saves you a bunch of costly refactoring if you want to make changes later on. And it avoids a bunch of those small outages where you want to update something, but you kind of forgot something else. If you're not careful, you go for a large outage instead. Try to avoid that as well, obviously. It's also very convenient to use this to enforce your standards and to lower your barrier of entry to people that actually want to use this. Someone might want to get into Terraform and go like, oh yeah, I'd like to deploy a virtual machine. I've got an application. I need to deploy this. I need a VM. I need a load balancer. I need a firewall rule. People might not necessarily know all the parameters that go into that. So what you do is you provide them with the module, and you say, okay, you want a firewall rule? Give me a source, give me a destination, give me a port, and I'll figure everything else out on the back end. You want a virtual machine? Brilliant. Give me a name, give me a location, give me a t-shirt size. You can choose what you provide as inputs for that module, and that allows you to enforce a bunch of your own standards, because whoever uses the module does not have that access to actually get the resources itself. And it allows you to lower the barrier of entry, because people don't need to know everything that goes into those resources.
So let's talk about how we actually run Terraform at our customer. As I said before, we want to avoid running Terraform on endpoints. You can download it to your laptop. We do not want our Terraform files or potentially state files spread out on people's laptops, because that might end up badly because of those passwords. We want it, because of those passwords, again, we wanted to make it as secure as possible and provide as many modules as needed, because we have people in a different country that might not be vSphere engineers, but that are instructed to create a new virtual machine, or people that are instructed to create a new firewall rule. While they may know how to do those actions, they may not know all the different parameters or variables they need to enter into the Terraform code to actually get that task done. So we wanted to make it as easy as possible for people to get on board with this. And as I said before, we wanted to limit write access as much as possible, especially to NSX, to our ALB, to whatever environment you're using Terraform for, or we are using Terraform for. We do not want anyone to have write access. That's not to say no account has write access, because we don't want people to wake up in the middle of the night, get called on the on-call, and then have to write code while they're half sleepy. So we do provide break glass accounts because we don't want to lock people out or anything like that. So those are a few things that we implemented. Now also, we went for an IAC platform. In our case, we do Atlantis, but you can use HashiCorp or Terraform Cloud, or there's a couple other providers out there as well. And management is done through pull requests. Now, that is a whole different can of worms that I'm not going to touch here, so I'm going to assume most of you will know how pull requests work. If not, talk to us afterwards and we can discuss this. But we just want people to write code, commit it to whatever source control provider you're using, GitHub, GitLab, Azure DevOps, whatever. Do a pull request. Then Terraform will do the plan, and it will output that plan as a comment to that pull request. Now, we also don't want people to YOLO new stuff in our environment. We kind of want to go through a verification process as well. So that's why we also enforce the 4 eyes principle. So in case I commit something, I cannot approve this myself. I cannot also get this deployed into production, which also ties back into why we have break glass accounts. If this happens in the middle of the night, I don't want to wake up somebody else to approve my code so they can go back to bed afterwards. I just want to be able to get that problem fixed and be done with it. By doing this, we have full traceability of whatever we do, because Git is fully transparent. Everything I do is in the Git history, so nobody can sneak in a change that will never be traceable again. It's all fully traceable. So that is how we run this, but I've bored you to death with slides, so I think now it's time for demos. So we've got a few demos prepared for you. We've got plain old Terraform. We've also got modules, and then we have a real-world example as well. So let me go over to my lab. Maybe first go over the code that we have. Is this readable? Oh, this is not good. Is this readable for everybody? I can increase it a bit. There we go. So this is what Terraform looks like. So in this demo, we are just going to put everything into a single file, which is not something that I can recommend. But just to go over the code real quick, this is something you will always have. So there will always be a Terraform block, and there will always be a required providers block. Now, as I told you before, providers are a way of telling Terraform how to talk to a specific product or set of APIs. In this case, we're going to use NSX. So you just specify the required provider as NSXT. The source will be VMware /NSXT. Now, if you use this, Terraform will look to the Terraform registry, which is public and accessible to everybody, and look for a provider that matches that name. You also have to specify a version of the module of provider you want to use. This is a fairly ancient one that I forgot to update, but I didn't want to break my demos just before this presentation. Joe, just imagine it says 3.6.2 and everything is fine. After that, you also have to tell Terraform how it can authenticate to whatever you want to talk to. In this case, this is NSX, so you have to tell it the name of your NSX managers. I just have one in my lab because of resource constraints. So this is my NSX manager FQDN. I also specified a username. In this case, it's just a service account. I'm not using any publicly trusted certificates or certificates that my Terraform machine will trust, so unverified will be true. And I want to try for 2 times to get in there. Now, you will notice this has no password. So how does Terraform know that I have a password or what the password is for this service account? Since I'm publishing all this code publicly, I did not want to set a bad example, so I use an override file. Now, an override file is a way to, and don't worry, this isn't a password that is actually used in production, so it's fine to present it. Now, an override is just a way to override something that is specified in your code. So in this case, I'm overriding the NSXT provider, and I'm just giving it the password variable. This is something that you should definitely put in your git ignore file the override.tf so you don't accidentally commit it to your Git repo. But as just a way to, if you're testing stuff out locally, you can easily set a password in there, and you can also still share your screen with coworkers and not give out your password. And we learned this the hard way. Going back to the... Sorry?
Yeah. Ideally, for your passwords, you're not going to put those in files because you're not committing your passwords to your source control. What you'll do is either you'll get those on the fly from, say, a key vault, and you'll add those as an environment variable in whatever platform you're running. So what we do, for example, is when we run Terraform, before Terraform runs its plan, a script is going to run, and that's going to pull all passwords, all private keys out of an Azure Key Vault, in our instance, and populate that as environment variables. And Terraform will read those environment variables to figure out what the actual password is to get into that specific platform.
Yes. So now we've told Terraform how to connect to NSX. In this demo, I'm going to create a new tier 1 gateway and also a logical segment. Now, before we can do this, Terraform needs to know a couple of things. For example, what is the tier 0 that you're going to connect the tier 1 to? In this case, I'm just putting it outright instead of using a variable, which is also a possibility. So I'm using tier 0-gateway. You also need to tell it what your transport zones are for NSX. In my case, this is just tz-overlay and tz-vlan. And now it's actually time to start creating a resource. A resource in Terraform is something you will create. A data object is something you will use as just information, and that will not change anything in your environment. If you do a resource, that will make changes to your environment. So in this case, what I'm doing is I'm creating a new resource tier 1 gateway, and I'm giving it the name t1-explore. This name is important because you can then later on use it again in your codes down the line. And you'll see this in just a sec. So what I'm doing is I'm creating a tier 1 with a description, with a display name. Failover mode and stuff is fairly default if you do it through the UI, but if you're doing it through Terraform, you just have to specify those variables. I also have to tell Terraform what tier 0 I'm attaching this tier 1 to. So this is where this data object comes back in. So this is data.nsx policy tier 0, the one I got before. This is the name I gave it. So if you look here, this is the tier 0 name that I gave this data object. And then Terraform likes to work with IDs or paths. So that is something kind of depends on the provider, what it expects. So you can find that in the documentation, but in this case, it is path. Once that tier 1 is created, I'm going to create a new segment. Again, this is a resource, and I'm using the resource I created earlier. So in this case, I don't need to do data.nsxt policy tier 1. I created it earlier, so Terraform knows that it exists, so I can just use that name outright. This all looks fun, but let's actually run this. And maybe I should... I'm not going to zoom in here. I'm just going to create a new terminal, and then I'm going to zoom in. This is Mac versus Windows, so I hope this works. Yes, it does. So I'm going to go and do it correctly. Now, when you first run Terraform, you need to initialize your repository because Terraform needs to actually go download that provider that you specified earlier and check a few other things. So when you want to do that, you just do Terraform space init. And that way you tell Terraform to initialize. So you can see that it found the module that we specified, it downloaded it, and then it just gives you a wall of text that is always the same and rarely changes. All right, good, this works. So as Evert mentioned before, we want to do a plan now. Let me just maximize this for more screen real estate. So now we're going to do Terraform plan. So now we'll take that code, it will look at the environment, and it will output what it's going to do. So in this case, where's my scroll bar? Here. You can see that it outputs a lot more than what we specified because it is going to output every single thing that is going to put into production. So it can be a bit verbose, but you just got to read through it and make sure that everything you do matches what you actually want to do. So in this case, you see a green plus sign indicating that it's going to create something. So you can see it's creating a logical segment Explore 01 with that subnet, and it's also creating a tier 1 gateway Explore. This matches what I want. So now I'm going to do Terraform apply. It is going to give me the same output, but with a prompt to confirm that I actually want to do this. So in this case, yes. And you can see it created it. Now, I don't want to say I don't trust machines, but I like to verify everything that I do. So let me just log into where's my Firefox? Just grab the password here real quick. So we're going to go to networking, tier 1 gateways, and you can see tier 1-explore. It is connected to tier 0-gateway, and there is also a new segment. Awesome, this worked. Nobody wants to do this more than once because this does not scale very well. So we mentioned before that modules are a thing. So let's do a demo for using a module. So you can see our main.tf file, so the main one we're actually running, is going to be a lot shorter. I created a module here to do the exact same thing that I did before, but now with a module, and it's going to be a lot shorter. So here what we're doing is I'm using the module Explore segment. I'm going to loop through everything that is in my TFVars file, and then I'm going to take that input of the map that I created in the TFVars file and use that to loop through whatever is specified in my module. The module is published on my GitHub page, so you can look at the code there. We do not have the time to go through the actual module itself right now. I've also created a provider.tf file. It's just the same as before, but this is a bit more scalable. Terraform will just take everything that's in the folder, bundle it up, and just run it. But for humans that are not good at concatenating, it is easier to just put it in different files. So provider is going to specify just what we use for a provider and all that stuff. We have variables files where we define what variables we're going to use, and then TFVars files that contain the actual variables or values of the variables that we want to use. So in this case, I'm providing a location that I'm using in the module. That's a variable that I added. And this is the map that I'm going to loop through. So here it says Explore-01 that I'm using as a name. A number 3 just so that I can keep track of how many segments I have, and a different CIDR subnet. So if we go back to the lab and we go to demo 2. So first I got to do Terraform init again. You need to do this for every single file because it downloads that to the folder that you're running in. So this is a bit tedious at times.
So you have to do it once. This may be an important context here.
Well,
you
yes,
run initialize once.
Once per folder for this demo. So I'm going to do a Terraform plan, and you're going to see that it's not going to do what I wanted to do because I didn't specify the actual variables file. So what I'm going to do now is Terraform plan --var file equals explore.tfvars. And then it will take those values that I added in that TFVars file and give me the output of the plan that it's doing. So this looks the same. It's creating a segment that is ls-explore3 with a different CIDR subnet. So good to go. So I'm going to do Terraform apply. And also have to specify the var file. var file equals explore.tfvars. It's going to do the plan again and confirm. And there we go. We've got a new segment, but just to verify, I'm going to refresh, and you can see ls-explore3, and it has that segment or that subnet that we specified earlier. Now, you can take it a step further, and this is how we will actually use it in production, but I'm going to hand it over to Evert, who is way better at explaining this than me.
All right. So that's nice. You've made a segment. That's not really a real-world example, right? If you run an NSX, you know you're not just creating segments all day. You ideally want to do a bit more than that. You probably want to create some policy rules. You want some services. You want to micro-segment your environment. That's why you bought it, hopefully. So how do you do that? Well, you combine a bunch of stuff. This is a demo that is fairly close to what we actually run in production. It's not the exact same thing. I'd love to show you our production repositories, but I'd probably get fired. But this is about as close as I can get without divulging our internal infrastructure. So what you see is our main.tf file. Don't fall off the stage.
No, I'll try.
It's mainly going to create, going to call a bunch of modules. What are we going to do? We're going to call a module for services. Why? Because we want to define our services separately. So we're just going to get our services. We're going to call a module for all our security groups. Again, we don't want to be defining all of those in that main file. We're going to get a module, and we're just going to standardize these. We're going to call some data. These particular data instances are to deal with built-in objects in Terraform. As I mentioned, anything that is not in the state file does not exist as far as Terraform is concerned. If you want to use services that are native in NSX, like SSH, HTTPS, FTP, you do have to actually get those as data objects. They exist, so you call those as data objects, so Terraform actually knows that they exist, and they can be used further on in your code. We're going to do a similar thing for groups. And then finally, we're going to call our policy. Now, what you have here is a 30-line file that basically describes your infrastructure. Kinda. Why is that? Well, the actual data is a bit longer.
Maybe you want to minimize that.
I want to minimize this indeed. Thank you. So as Maarten has showed, you can run that file, and it's just going to ask you for values for every single variable that you've defined. You don't want to do that, you run a vars file. So what we have here is a tf vars file that contains all the values we want. We have a list of all our security groups that we want. Now, this is obviously a short list. You're running production, this list is going to be much longer. You ideally will have this in separate folders as well. But you'll see here we have a few groups. And how do we define those groups? Well, we just use tags. Why? Well, you don't want to use IP addresses in general in NSX, not necessarily the subject of this talk, but you want to tag as much as you can. Ideally, you tag your things in vCenter, and you use
VBA.
You use VBA to sync those tags back to NSX, or you tag them directly in NSX, if that's your jam. And what do? We say, well, we have a group AD, in our case, Active Directory. What do we want in our group AD? Whatever has a tag AD, whatever VM has a tag AD. That works for a lot of stuff. That might not work for everything. For example, if you're running the AVI load balancer, it does create a bunch of objects for you in NSX, but it won't actually create your VIP objects for you. So if you want to make policies for your VIPs on the front end, you'll make IP object groups, for example. Sometimes you might not have things that you can use tags for. That can be stuff like a VIP. That can also just be stuff that's not running in your virtual environment. If you have a physical appliance, for example, that's when you can use IP groups. Or in this particular module, you can just combine them as well. For example, our Exchange environment, we have a few VIPs for that, but we also have our Exchange VMs. Whatever has a tag Exchange will get added to the group, but those two IP addresses in here will also get added to that group. Next up in here, we have our services. Again, you're probably not going to rely only on services that are already defined in NSX for you, unless you're running in a lab, or unless your particular organization is a utopia where you have 3-tier web apps, where you have a nice little web server with a predefined application server that's all running on standard ports, talking to a standard SQL on the back end. You're going to have to define your own services. How do you do that? Well, in our instance, they're a similar way to how you define your groups. We have our services for AD here. There is a built-in object in NSX for Active Directory. It was missing some things that we needed in our environments. So we created our own group for this.
We also had TCP/25, which you don't really want to have open towards the domain controller. So
exactly. So we have defined a few groups here. Again, how do we do this? Well, the service AD, whatever TCP traffic passes on this set of ports, or whatever UDP traffic passes on this set of ports. As I mentioned, we then have built-in services. I don't think our demo uses these necessarily.
No. It's just to highlight why you would want to do this or how you can then use this in the policy. And I think there might be an HTTP one, actually.
Yeah. So any service that we want to use in our policy that exists in NSX out of the box, we're just going to add these here. And then we have our actual policies. And this is something that I think highlights the executable documentation. We have in here a few policies that we want to apply to NSX. Namely, an ICMP policy, a domain policy, and a DFS policy. What do you see in here? And this is, all right. Our environment says we allow ICMP echoes everywhere because you should, because otherwise things break. What do we do here? Well, this is our ICMP policy. It is in the infrastructure category. You know NSX, it has a few categories in there. Infrastructure, environment, application. We want to add this to the infrastructure policy. We want it to be number 7, because 7 was a nice number in this instance. You want all of those numbers to be unique. This also defines the order in which your policies will be added. And in this particular instance, we want one rule. We want to allow ICMP echo. We allow ICMP echo from anywhere to anywhere, as long as it's an echo request. We don't want to go fucking around with random ICMP protocols where people want to send random stuff. We don't want that, but you're allowed to send in echoes. That's all good. We tell it that our scope here is anything, so we want to apply this to the entire distributed firewall. We want to allow it in either direction. This is a single rule, of course, that's not ideal. We also have this for our domain, so our Active Directory services. This is a bit more complicated. So you'll see here the scope of this rule is our Active Directory infrastructure. Now, this is not just our domain controllers. We also have our certificate authorities in here, for example, and I believe our KMS for Windows activation. We also have it grouped under that. So what you see, what we have in here is, well, we want devices to be able to talk Active Directory to our domain controllers. That's why we have them. So what we do, we say anything can talk Active Directory to our domain controllers. What can they use for that? They can use the service we created before, SVC AD. We also want people to be able to talk to our certificate authorities, right? They need to be able to request a certificate. You want people to be able to actually fetch a CRL. So in here, what we say, well, anything can also talk HTTP to our certificate authority VIP. Also still very straightforward. We have a similar rule for our CAs, right? So our clients can talk to our CAs, refresh certificates. Then we have KMS in here. So you can see we have a few rules in here. And then in the end, we have a catch-all rule. In this particular instance, this is what we would do if we're migrating in brownfield application, where you go, well, I want to micro-segment this, but I don't necessarily know anything that has to talk to this. And I've talked to my developer, and he doesn't know the alphabet. So we're going to start by building a policy, and we're going to allow this for a brownfield application. And we're going to create a catch-all rule. So whatever we haven't actually firewalled yet, we're going to allow this. Good. And once we're certain that we've got everything, we'll enable the default drop rule and be in a secured state. In this particular instance, it's still our catch-all rule. We haven't checked if everything is working, so we still allow it. And then finally, we have a DFS rule, which has a DFS policy, rather, where we allow SMB traffic to our distributed file system. And we do have a default drop here. Now, we can also actually deploy this.
Maybe you should talk about the state file as well.
Yes, I should talk about the state file.
It's VS Code.
Now, this demo, because it's more real life, we actually have a remote state. How would you do that?
Provider.
There you go. You define a backend. So again, you'll see the Terraform block that Maarten has explained before. We have our required providers in here with, say, you need NSX, go download it, or get it from your cache. But store your backend on Azure. We have a resource group for that. We have a storage account name for that. And then we have a name for our file and a name for our container. The exact syntax for all of these things, no one expects you to memorize all of this. HashiCorp has documented all of this, of course. In essence, it translates directly to whatever API you're abstracting, but that documentation is all on the HashiCorp website in that provider documentation. So in this particular instance, we're using an Azure backend. Why? Because we want multiple people to be able to do changes to this environment. We also have a TXT file in here.
That is just for us.
This is just
want to memorize the commands.
This is for the demo's purpose.
In production, this runs in the container that actually grabs the state file. So anytime we run that pipeline for us, the container will run a shell script that will do the AZ login and just grab all those environment variables, put it in there, and afterwards remove them. So that way, the environment variables only exist in memory of that container for the duration of that plan and apply to make it as secure as we could possibly make it. Yeah, screen real estate is a bit short.
Ik heb geen rechtse klik. My right click is...
Yeah, if you want, I can...
There we go. This is not very readable, but essentially we're just logging into Azure here so we can actually reach our state file. So again, we're going to initialize, and you'll see here, initializing the backend, it's no longer a local file. It's now actually Azure. And you can also see if this... It is somewhat slow. This is running in Belgium, so we do have some latency here. You'll see it's also went ahead and downloaded all our modules that we're using in the code here.
As I said before, we were using the public registry for the provider of NSX. In this case, we're using a private registry to host our modules. And you can do this on HashiCorp Cloud, or you can use TerraReg or a couple of other providers that mimic this as well. So this is just a private repository where you can store all of your modules and create documentation like what input variables that it needs and all that stuff. FAR file is the one you want.
Yes, thank you. So now we're going to plan this again. If I make no typos, at least.
Dash file.
And as you can, sorry, the VAR is here. Oh no.
Yeah, it's there. Yeah.
Yeah, it's for the VAR file. No, I forgot a dash. You can see how often we run this in the command line. So you see right now, it's going to add 19 resources. We didn't add 19 resources. We added modules, and we updated the DFVARs file. If I then apply this, there we go. It goes fairly quickly. How quickly this goes depends on the size of your environment, the size of your folders. But if you then go take a look in NSX at our policy, you see we have a few policies in here now. We have our ICMP rule, we have our DFS rules, and then we have our domain rules. And that's roughly how we run this. There's a bit more to it. We have a block for deploying virtual machines, for adding tags, for example. We have limited time. So yeah, we can't really showcase all of that. If you do want to know more, we'll be happy to take your, we'll happily take any question you have. We
still have a whole 47 seconds to answer any questions on stream. Otherwise, we'll happily take them off camera. And with that, yeah.
Yes. So the question was if there's a feature to actually update your code with changes that were made manually. There is. You can import resources into Terraform. If someone has made changes to resources that you manage with Terraform, you can just update the codes and run a plan, and Terraform will then see, okay, your code now matches, that's fine. If someone has created a resource, you can write the code for that resource and just import it into Terraform. If you don't do that, that's how things get destroyed and updated. Oh, you get a token for this.
Any other question? Yep. Sorry?
Because it's a stateful team.
Yeah.
What happened is sometimes colleagues may not be quite familiar with what's going on or only familiar with certain modules. Then they start changing things and not knowing that that was a stateful change that they made and also affect the production or anything that was happening.
Yeah.
So destroying things, that is exactly what's happening and how we try to not do.
That is also the reason why we removed write permissions for everybody, just to avoid scenarios like that. We do not want people to actually go in and make stuff on their own. We want everything managed through Terraform. That being said, we do have those break glass accounts that we use. But the rule, I say rule, but the guideline is that if you make a change during the on-call or during night with one of those service accounts, is that you also commit it to code and then apply it the day after so that the state matches again. That being said, it's a good thing to put alerting on those service account logins so you keep track of that because people are going to forget.
What we did was we created a two separate environments.
Yeah.
One is the test, the other one is the production that everybody touches that. So we did the dry test run on the test first to make sure that it's doing exactly what we expected. And then if we make some mistakes, then we can change it, but it's already on the test stage anyway.
Yeah.
The other part of it, we also have sometimes things we're doing correctly, but the error could be something else on the module. I'm talking about bugs. So, and of course, bugs cannot be found later on after you implement it. And usually already 6 months down the road, then, oh, we have this issue like the NSX 4.2.
Yeah.
So, VMware come out with, oh, we had a hot patch for that, right? But we already deep into that. So we had a version control. So basically, we had a choice of reverting it, and if we do revert, how many objects that will be affected, if that is something worth it or not to do.
Yeah.
So that's what we did. That's right.
I think we've just about run out of time here. Sorry, I don't want to interrupt.
Yeah, maybe
we'll happily continue this after the session. If you have any questions about this, we're both here all week. You can find us on the Explore app. You can follow us on Twitter, X, Twix, however people like to call it. Maarten blogs at Brisk-IT.net. I blog at Amcom.io. We're both on LinkedIn, all the usual stuff. We're in the V community Discords. Go find us there. You're welcome, Frankie. But that's all we have. So, yeah, thank you for staying with us.
Please fill in your survey. Thank you. Have a good one.